Hello students, am I audible, sir? Hello students, am I audible? Can you please comment in the comment box? Students, am I audible, sir? Hello students, am I audible? Can anyone please comment in the comment box? Okay, thank you, thank you. Okay, thank you for your response. Thank you. Okay, so welcome to IMS Gate Academy. Students, there was a small technical glitch, so I was late by 5 minutes. Sorry for the inconvenience. Hi students, welcome to IMS Gate Academy. As we are inching towards the gate exam, it is the time to revise yourself. Then what are you waiting for? We at IMS Gate Academy YouTube channel, we are providing the conceptual series with the gate score booster who are aware of the concepts. If they want to practice the real time application oriented problems, then definitely you have to visit the IMS Gate Academy YouTube channel. Myself Sandeep Adari, today I am here to discuss about the concepts of surveying. Okay, see students, now in IMS Gate Academy, if you want to get any updates on the YouTube channel, in the IMS Gate Academy YouTube channel, we have provided the Telegram link and you can join that link where you can access the classroom notes which we have discussed in the YouTube. And also if you want to practice some quiz questions which are beautiful questions, and apart from that, if you want any updates from IMS Gate Academy, definitely you can access this Telegram group channel. Now my dear students, I am really excited to say that we at IMS Gate Academy offering offline gate coaching at Bangalore and also at Vijayawada near the bench circle. At Bangalore, we are offering the offline gate coaching near Jayanagar. And remember my dear students, we are giving 800 plus hours of live online gate coaching as well as offline gate coaching. In this gate coaching, we offer you the study material which consists of chapter tests, and also we have subject wise material, and we have an exercise book where it consists of level 1, level 2 and level 3 questions. And remember my dear students, we are really excited to share you the 30-year previous year gate question booklet with all the key pointers and with the detailed video solutions. Not only these students, if you want to practice yourself, then you have to definitely have the test series. In the test series, we have chapter test, subject wise test, multiple subject test, advanced level test. And remember my dear students, we are also giving you the advanced level test, all India mock test series, which will be the exact replica of the gate environment, how you are writing. Okay students, now when I talk about the all India mock test series, here the same as the gate environment, we are providing 12 test series. And remember my dear students, the key success for IMS Gate Academy student journey is one is the My Plan session with one-to-one mentorship with the students, and also students, we are offering doubt solving portal. If a student has posted the doubt in the doubt solving portal, within 24 hours of time, the doubt has been resolved. So these are the exciting features of the IMS Gate Academy. Be a part and parcel of IMS Gate Academy and achieve your success. Now quickly we'll enter into the question topic students. Now see students, in surveying, let us study about the surveying, which you call it as geomatics nowadays. Now see students, how the journey of geomatics has happened, my dear students. How the journey of the geomatics has happened. Now see students, this is a very, very beautiful concept. Suppose if you want to measure the distance between two lines, A and B. So my dear students, to measure the distance between 2 points, we have used a chain surveying which is done by linear measurements. It can be measured using a chain or it can be measured using a tape. So the distance between 2 points is measured using a chain or a tape. Agree my dear students? Now, if you want to measure the distance between if you want to measure the distance between 2 points but with an inclination theta. So here you should know the theta value to find out the inclined distance. For this, my dear students, we are calculating the angle theta with the help of a compass surveying. Are you getting, my dear students? Initially, the distance between 2 points is measured with a chain or tape, and the inclined distance is measured with a compass. And my dear students, if you want to measure the vertical angles and also the horizontal angles, suppose, see students, if this is a station we have, if you want to measure the vertical angles or the horizontal angles, you can measure using which instrument? Can anyone tell me? Can you comment in the chat box? You can measure using a theodolite. What you can do? You can measure using a theodolite. Now see students, let me tell you, if you want to automate all these three things into a single instrument, that is nothing but total station. If you want to make all these things into a single instrument, then it is a total station. Now my dear students, what is a total station? A total station is a combination of electronic distanceometer and electronic theodolite. So what actually is electronic distanceometer? To measure the distance between 2 points, my dear students, instead of chain or a tape, you have to measure manually. But with the total station, with the optics principles, it measures the distance between 2 points automatically. In addition to this, it has the feature of electronic theodolite where the angles can be measured. So this is how the transition, how the surveying has came down now. Now my dear students, suppose there is a disaster and that disaster is happening and you want to visit some hills or anything, then you can use an unmanned aerial vehicle or aerial vehicles to observe what is happening in the ground level. That is nothing but the photogrammetry. So my dear students, let me tell you about the topic photogrammetry. Now let me tell you the topic photogrammetry. Now see students, what do you mean by photogrammetry? Now what do you mean by photogrammetry? Photogrammetry is the art of science of obtaining reliable information about the physical objects by the process of recording, measuring and interpreting the photos. Suppose, see students, you have an unmanned aerial vehicle here and you will be taking the photos from here which are on the ground. So by using the principle of recording, means recording has been done with the camera, and measuring has been done with the principle of optics. Using the principles of scale, we are doing the interpretation. Again, I will repeat the point, my dear students. Photogrammetry is the art of science of obtaining reliable information about the physical objects by the process of recording, measuring and interpreting the photos. Now, my dear students, I am just giving, as we are not going in detail of the concepts, but I will give you an overview once we are solving the problem. Here, if I talk about scale, scale can be taken as focal length upon capital H. So what is F here is, F is nothing but the focal length and capital H is the flying height. Capital H is the flying height. Scale is nothing but focal length upon flying height. And remember, we have different scale formulas. Scale is equal to F upon capital H minus small h. If suppose the object, if you are standing on top of a building and you are taking the camera, then it is h. And if you see students, if the ground surface is irregular, then we have come up scale is equal to F upon h minus h average. So remember, what do you mean by scale of a photograph is nothing but scale of a photograph is defined as the ratio of photo distance upon ground distance. How scale of a photograph is defined? Scale of a photograph is defined as the ratio of photo distance to the ground distance. Agree students? So we have three different formulas. When the photograph is taken, when the ground surface is planar, it is F by H. When you stand on top of a building or anything, it is defined as F upon H minus H. And if the ground surface is irregular, then a F upon H minus H average. These are the three formulas for photogrammetry, how to calculate the scale. Now let us go directly into the problem, students. Now see, students, if the size of the ground area, if the size of the ground area is 6 kilometer into 3 kilometer and the corresponding photo size is 30 centimeter into 50 centimeter, then the scale of the photograph is. Very beautiful question, see students, very beautiful question. Now see students, as I told you, scale of a photograph, scale of a photograph, scale of a photograph, scale of a photograph is defined as the ratio of, can anyone tell me, my dear students? Scale of a photograph is defined as the ratio of photo distance upon ground distance. Scale of a photograph is defined as the formula photo distance upon ground distance. Agree, students? Agree or not? Very good, very good. So here we have a photograph size of 6 kilometer into ground area is how much, sir? Ground area is 6 kilometer into 3 kilometer. My dear students, the ground area is 6 kilometer into 3 kilometer and the photo size, ground area or photo area size is 30 centimeter into 15 centimeter. Agree, students? Now see, students, you can either take 6 kilometer or 30 centimeter. Either these two you can take because this comes under lengthwise, and these two you can take if they are comes under breadthwise. So I will be taking these two values, 6 kilometer and 30 centimeter. So photo distance is how much? Lengthwise it is 30 centimeter upon ground distance is how much, sir? 6 kilometer. Now my dear students, to solve this problem, you know already 1 kilometer is equal to how much distance? 1 kilometer is equal to 1000 meter. What is the value? 1 kilometer is equal to 1000 meter. And we know 1 meter is equal to how much, students? It is equal to 100 centimeter. So my dear students, 1 kilometer can be taken as 10 power 5 centimeters. So 1 kilometer can be taken as 10 power 5 centimeter. Now if I plug in those values here, this can be taken as 30 centimeter upon 6 into 10 power 5. If you solve 6 5s are and 5 divided by 1 lakh, it will be equal to 1 upon 20,000. This value will be equal to 1 upon 20,000. See students, this was a GATE question asked in GATE 2023. So my dear students, what are the key takeaways from this problem is, you should know the scale of a photograph. The scale of a photograph is nothing but the photo distance upon the ground distance. So here I know the photo distance is 30 centimeter and ground distance is given in kilometers, and you have to ensure to calculate the scale, photo distance and ground distance should be in the same units. By plugging these values, you will get the values answer as 1 upon 20,000. I hope this solution is clear for you. Thank you. Now see students, please read this question. I will give you 1 minute of time. Now see students, the question here is, an aerial photograph of a terrain having an average elevation of 1400 meter. Average elevation is how much, sir? 1400 meter, and a scale is how much? 1:7500. The focal length of the camera is 15 centimeter. The altitude of the flight above the mean sea level. Now see student, he is asking, what he is asking is, suppose if I consider this as a unmanned aerial vehicle, we have a camera here. So this is the ground surface. The distance from the optical center of the camera to the ground level, we call this as flying height. We call this distance as how much, sir? Flying height. Now see students, they have given in the problem, what is the scale value? Scale value is given as in the problem. Scale is equal to 1:7500. What is the value of scale, sir? The value of the scale is given as 1:7500. And remember, my dear students, focal length is given as 15 centimeter. Okay. And they have given you, sorry student, they have given you the average elevation terrain is 1400 meter, and the flight and the average elevation above the terrain is how much, sir? The average elevation above the terrain is how much? 1400, right? It is 1400 meter. Now see students, they have given you the scale value, they have given you the focal length, and they have given you the average elevation. Now see students, here you know the scale formula. Scale is given by the formula F upon H minus H average, where F indicates focal length, capital H indicates the flying height, H average is the average elevation given. Now see students, scale is given as 1/7500. 1/7500. See students, here focal length is in centimeter. So you have to convert this into the meters, because both should be in same units, I told you. So this will be equal to 0.15 meter. So this will be so focal length will be equal to 0.15 meter upon flying height, you don't know, capital H minus H average is 1400. So you can write here H minus 1400 is equal to 7500 into 0.15. Okay, so this value 7500 into 0.15, this value will be equal to how much, students? 375. So 1125 meter. Now if you add 1400 to this, flying height is equal to 2525 meter. Okay, now what is the flying height? Answer here is, you can say the flying height is given by the answer as 2525 meter. So again I told you, see students, just you have to apply the scale function here. Scale is nothing but focal length upon H minus H average. See students, H average comes into picture means that is average elevation. Or you can remember that when the terrain surface is irregular, then average elevation comes into picture. When the terrain surface is irregular, then average elevation comes into picture. So here scale is equal to F upon H minus H average. 1/7500 is equal to 0.15 upon H minus 1400. On solving, we get flying height is equal to 2525 meter. Now see students, this is a very important point, students, let me tell you. For this, see students, to calculate the number of photos, let me tell you one concept. To calculate the number of photos, okay. Here see students, here we have, suppose this is the ground area. If I consider this is the ground area, and if I consider here photo of one area. Now see students, if I take capital A as the ground area and small a is the area of each photo. So number of photos, here number of photos will be equal to, number of photos will be equal to, number of photos will be equal to what, sir? It will be equal to ground area upon, it will be equal to ground area upon area of each photo, ground area upon area of each photo. So here this will be equal to capital A upon small a. And remember, to calculate the number n, both ground area and photo area should be in same units. Now see students, when I talk about here what I would like to tell you here is, here there should be a overlap. This overlap we call it as longitudinal overlap. What is this overlap we call? We call this overlap as longitudinal overlap. See students, usually it should be equal to 60%. If you considered the, usually what is the percentage to have desirable percentage in longitudinal overlap is 60%. Similarly, we have this portion, whatever we are having here. Okay, whatever we are having here, this we call it as side overlap. Whatever we call this as what, students? This we call it as, this portion we call it as side overlap. So see students, PS is known as side overlap, and PL, this usually we take it as 30 percentile. How much value will take? This value will take it as how much, sir? 30 percentile. So my dear students, if I talk about the optimal flight planning, if you talk about the optimal flight planning, okay, then there should be both side overlap as well as the longitudinal overlap. So remember, the answer here is, it should have only side overlap? No. Only end overlap? No. Either side or no. Both it should have, option D, it should have both the side overlap as well as end overlap. End overlap is nothing but the longitudinal overlap. Now see student. Now here let me tell you another important thing, Amma. Here let me tell you another important thing is, how do you calculate the length of photo, or you can say, or we can say number of photos. How do you calculate the number of photos? Number of photos is given by the formula n is equal to ground area upon area of each photo. Agree students? See, now if I talk about the capital A, and area of each photo can be written as L into 1 minus PL by S, okay, into W into 1 minus PS by S. Sir, this is the formula by finding the effective length of the photo and finding the effective width of the photo. What is S here is, S indicates scale. S indicates scale. And what is PL? PL is nothing but the longitudinal overlap. PL is nothing but the longitudinal overlap. And PS is nothing but the side overlap. PS is nothing but what, sir? Side overlap, or someone will tell you longitudinal overlap as end overlap. Now my dear students, here what I would like to tell you is, see, this is the formula to find out the number of photos, taking consideration calculating the area of each photo. We can calculate the number of photos using the other method also. See students, you can calculate the number of photos using the other method, that is n1 multiplied by n2. What, sir? n1 multiplied by n2. What is n1 means? n1 is the number of photos in a strip multiplied by the number of strips. So see students, if I consider this as a ground area, if you consider this as a ground area, and if I consider this as a strip, and you have different photos here, right? So this is considered as strip, okay? This, so n1 represents what, sir? n1 represents the number of photos in a strip, my dear students. What is n1 represents? n1 represents the number of photos in a strip. Okay, and what is n2 represents here is, if you can have different number of strips here. you can have different number of strips here, okay, like this. So N2 represents the number of strips. N2 represents number of strips. Now my dear students, how to calculate N1 and N2? We have a formula. If we consider this as the width of the ground W and here L is given. Now my dear students, let me tell you when to use this method and when to use this method. See students, this method is useful when a ground area is given. This method is useful when a ground area is given. And remember here length of the ground and width of the ground. Some smart people will ask me, sir, can I do L into W and do the first method? No. You have to take the second method when the length of the ground and width of the ground is given. Here N1 can be written as capital L upon L into 1 minus PL by S plus 1, and N2 can be written as capital W upon small w into 1 minus PS by S plus 1. So here this is the values related to N1 and N2. I hope you are clear how to calculate the number of photos. So this is the easiest formulas, but remember again and again I am stressing students, this formula is applicable and the ground area is given, and this formula is applicable when the length of the ground and width of the ground is mentioned. Now this is a beautiful concept students. Now a tall tower was photographed from an elevation of 700 meters. So let me tell you the concept before solving this problem. So this is nothing but the relief displacement. The concept is related to what students? It is a concept related to relief displacement. Okay, I will not derive the problem, but I will show you what do you mean by relief displacement here. See students, if I talk about relief displacement, just give me a second. Or you can say here, suppose we have a line here. Okay, now this is the ground surface and we have a camera here, and this is the focal length here we have. Okay. Now see students, this we call it as focal length F. And if you see students, there will be two lines here. If we consider here, this is the radial distance to the top. Now see students, here we have 2 points. This we call it as R1 and this we call it as R. Okay, this we call it as R. Now see students, you know this is the height of the object, a tower or anything. This is the height of a tower or anything. And if I assume this distance is equal to capital R, okay, and the distance from here to here is nothing but flying height. Now see students, this is how you have to draw the relief displacement. Okay, what do you mean by relief displacement? It is the lateral shift of the image of the object from the principal point. See students, if the point is exactly here, there will be no relief displacement. Means both the lines will coincide. Are you getting me? The relief displacement is nothing but the lateral shift of the image of the object. Again I am repeating, it is the lateral shift of the image of the object. Suppose if the object is here, both will be perpendicular and you will not see any relief displacement. And remember students, relief displacement is helpful in solving to find out the height of the object, height of a chimney, height of a building. So it has very good principles. So here if I consider delta R is equal to R1 into H upon capital H. This is the formula, students, for relief displacement. Everyone, you have to remember here what is delta R. Delta R here is nothing but, my dear students, here delta R is nothing but the relief displacement. Delta R is nothing but the relief displacement. And you should also know, students, how do you calculate delta R is, delta R can be taken as R1 minus R, where R1 is the radial distance to the top of image, R is the radial distance to the bottom of image. Okay, here see, students, capital H is nothing but the flying height. Capital H is nothing but the flying height. And small h is nothing but the height of the object. Small h is nothing but the height of a tower, height of a building or anything. You can say height of a object. Now let me tell you some important observations. If the flying height increases, relief displacement decreases. If the height of an object increases, relief displacement increases. So if the flying height is going to increase, relief displacement will decrease. If the height of the object increases, definitely relief displacement increases. So what is relief displacement is? It is the lateral shift of the image of the object. Relief displacement is given by the formula R1H upon capital H, where capital H is the flying height, small h is the height of the object, R1 is the radial distance to the top of the image. Now let me solve this question, students. Here a tall tower is photographed from an elevation of 700 meter above the datum. What, sir? And the radial distances to the top of the principal points are 112.50 and 82.40 mm. If the bottom of the tower is at 250 meter above the datum, then height of the tower is. Now see, students, here what he has given is, see, here you have taken a flying height here, you are taking the object, and here there is some object here, right? Now see, students, he has given in the problem, this is at a height of, how much, sir? 700 meter, okay, flying height. But the tower is standing at a height of, this is 250 meter, okay. Now see, student, if you consider this, what will be the relief displacement formula? What is the, is asking what is this height, okay. Now see, students, for your information, just now I told you how do you calculate relief displacement? Relief displacement delta R is given by the formula R1 into H upon capital H. See, students, here you should remove this 250 meter also, because capital H means it is the height from the ground to the optical center of the object. But here we will consider from the level of the object, means where the tower has been placed. So we should not consider 700 meter. Here if you, from similar triangle concept, this will be taken as 450. I don't want to derive it. So here you should take H minus H dash. I will take this as H dash. Okay, so delta R is how much, sir? Delta R is nothing but radial distance of the top minus radial distance of the bottom. So what is the radial distance of the top they have given? They have given the radial distance of the top is 112.50 mm minus radial distance at the bottom is 80 point, how much, sir, they have given? 80.1, I think. 82.40. So it is given as 82.40. So the relief displacement, the radial distance at top minus radial distance at bottom. So this will be equal to 30.1 mm. This will be equal to how much, sir? This will be equal to 30.1 mm. Now here if you see delta R is how much, sir? 30.1 mm is equal to radial distance at top. This value you have to remember also. This is in mm. Our radial distance at top is 112.50 into H, you don't know. And capital H minus small h, you can H dash as 750 minus, 700 minus 250. Now see, students, here this is in mm. This value is in mm, but this value is in meter. So this mm cancel. and here this value if you do, it will be taken as 4 times. So h will be equal to 30.1 into 4 meter. So the height of the tower will be equal to 120.4 meter. So here what will be the answer, sir? The height of the tower will be equal to how much, students? It will be equal to 120.4. So what is delta r? It is the difference between the radial distance to the top and bottom, and we have got delta r as 30.1. Here R1 is the radial distance at top, H is the height of the tower, and as we are considering the capital H minus H dash because it is the distance from the bottom of the tower to the optical center. So actually it was given as 700 flying height. The tower is at an elevated at a height of 250 meter. So 700 minus 250, you will get a value of 120.4 meter. I hope this relief displacement problem is clear. We'll solve another problem on relief displacement to get a better understanding. And it's one of the beautiful question. So students, I'll give you 1 minute of time. Just go through this problem. Now let me tell you these problems. There are two towers stand vertically on a horizontal ground. The length of the image of the tower. Remember I told you, see students, if they tell you what is length of the image, delta r, this is nothing but what I told you, students. This is nothing but the relief displacement. Delta r is nothing but what, students? This is nothing but the relief displacement. Delta r is nothing but what, students? This is nothing but the relief displacement. But here, what is the functionality of delta r, or what is the application of delta r? Here through delta r, we can find the length of the image. Okay, so don't worry that if they give you length of image means what is that value. For your information, if they give you in a scale, if they are measuring the length of image on a paper or anything, indirectly it is the relief displacement. So they have given delta RA for tower A, they have given as 1.5 centimeter. And remember, my dear students, for the tower B, what is the delta RB for tower B is given as how much? It is given as 2 centimeter. For tower A it is 1.5 and tower B it is 2 centimeter. And remember students, the distance of the top of the tower A. So the distance to the top of the tower means it is the radial distance to the top of the tower of the image. So here R1A can be taken as 4 centimeter. And the distance of the tower B to the top is 6 centimeter. So R1B can be taken as 6 centimeter measured from the principal point. That is very important, sir. These are the distances. These are the distances which are measured from principal points actually. Okay. These are the distances which are measured from principal points. Now see students, the photograph, if the height of the tower B, see students, here height of the tower B is how much? Height of the tower B is 80 meter. He is asking what is the height of the tower A. So let me draw the concept, or let me draw the diagram to have a better understanding, students. So what is the relief displacement? Relief displacement is nothing but the lateral shift of the image through relief displacement, we could find the height of a tower or a building. These are the applications. Now, to understand this diagram in a picture, suppose see students, if I have taken, there is a tower A which is of HA, and we have another tower B, okay, which is of height HB, and this is of height HA. Now see students, here we have one diagram drawn in this way, and this is the radial distance to the top, because they have given the radial distance to the top, okay. Now see students, if we considered in both the cases, the flying height is same, okay. Now see students, height of the tower B is given. Height of the tower B is given as 80 meter, and delta R is given as how much, sir? Delta RB is given as 2 centimeter, I think, and R1B, radial distance to the top, is given as 6 centimeter. Yes or no, students? And there R1B is 6 centimeter, 2 centimeter. Height of the tower B is 80 meter. Now see students, relief displacement delta RB can be given as R1B into height of the tower B upon flying height. Now see students, this question is simple if you could draw the line diagram, or if you can understand in a diagram wise. Now see, just plug in these values. Delta RB is how much, my dear students? It is 2 centimeter, and the radial distance at the top is how much, students? It is equal to 6 centimeter. And the height of the tower, which is given in the problem as 80 meter. So when you have done these values, divided by capital H. Now my dear students, the value 6 divided by 2 is 3, and the height of the tower is 3 into 80 meter. So the flying height can be taken as 240 meter. What is the flying height? The flying height can be taken as 240 meter. So my dear students, what is the flying height here? The flying height value is nothing but 240 meter. Now how do you calculate the relief displacement at A? So here you can write the relief displacement at A can be taken as R1A upon height of the tower A upon flying height capital H. Now see students, he is asking the height of the tower A. Now you know already delta R1A is nothing but 1.5 centimeter, and R1A radial distance to the top is 4 centimeter. So 4 into height of the tower you don't know, but flying height will be same for the tower B and tower A. Very good, Sai Srujna. This value is equal to 240. So upon 240, so height of the tower A, this will be equal to 60 meter. So height of the tower A will be equal to 60 into 1.5 meter. That will be equal to 90 meter. So height of the tower A will be equal to 90 meter. So whenever you are solving these kind of problems, students, I would like to give you a suggestion. Go through the diagram, understand what is R1A. R1 is the radial distance to the top. What is small r? It is the radial distance to the bottom. The difference between the radial distance at top and bottom is the relief displacement. And relief displacement is given by the formula R1 into H upon capital H, where R1 is the radial distance at top, H is the height of the object. It can be a tower, building or anything. Capital H is nothing but the flying height. Here whenever you have to understand, capital H is the distance from the optical center of the camera to the ground level. And if the building or a tower is placed at above some height, you have to deduct that height when you are placing that capital H formula in relief displacement. These are the two classical problems where you can solve the relief displacement problems and have a better understanding. Now let us go into the next topic, students. Now see this, I'll give you 1 minute of time. Just go through this question for a minute. Now see students, welcome back. Here we have a beautiful question. The error in measuring the radius of 5 centimeter circular rod is 0.2 meter. Sorry, 0.2 percentile. If the cross-sectional area of the area is calculated, then the resulting absolute percentage error in the computed area is. Now see students, they have given the error in measuring the radius of a circular rod is how much, sir? The error in radius of a circular rod is given as 0.2 percentile. Okay, how much it was given, sir? The error in radius of a circular rod is given as 0.2 percentile. Now if I talk about the area of a circular rod, area is given as what, sir? Area is equal to circular is pi r square. Now what do you mean by error in computed area is asking. So let us do capital A is equal to pi r square, and if I do the differentiation, dA is equal to 2 pi r into dr. Okay. Now see students, what is the error in computed area means is asking the value of dA by A. What is this value is asking. Now to solve this, you can simply plug in these values. dA by A, what is area? dA is how much, sir? 2 pi r into dr upon capital area is how much, sir? Pi r square. So here you can write it as pi cancel. You can write it as r square cancel. Here you can write 2 into dr upon r. Okay, what is dA, sir? You remember here students, dA by A, the error in area dA by A is equal to 2 into dr by r. So here you can write, they have given already, the error in radius is dr by r is given as 0.2 percentile. So 2 into 0.2 percentile, this is equal to 0.4 percentile. So this value is how much, sir? This value is equal to 0.4 percentile. I hope this solution is clear for you. Now please solve this problem, students. Okay, see students, here whenever they have asked you this question, see in the previous question we have done what is the error, right? Error in area. So we have calculated, we know the area in terms of r, and we have differentiated. So the error formula is dA upon original area. We got twice the error in radius. Now what he is asking in this problem, my dear students, is a horizontal angle theta by the different surveyors has multiple times and was repeated below. What is the most probable value of the angle theta? So he is asking in the problem clearly, what is the most probable value, my dear students? So here, what is the most probable value if they have given you? If they means here number of observations is how much, sir? 4, 3, 8. Okay, and this is the angles which are observed. You can write most probable values can be written as sum of weightage into observed values upon sum of the weightage. Weightage means how many times we have observed the values. So here we have observed the values, number of observations is how much, sir? 4, 3, 8 and 4. If you add this, you will get a values of 19. So in the first case, the most probable value will be equal to 4 into 36 degree 30 minutes. So here how many times you have done? 4 times, and the value you got is 36 degree 30 minutes. And in the third time you have done 3 into 36 degree minutes plus we have 8 observations which is equal to 35 degree 30 minutes. So 8 into 35 degree, 30 minutes plus, here we have 4 observations of 36 degree, 30 minutes, plus 4 into 36 degree, 30 minutes divided by the number of observations, that is 4 plus 3 plus 8 plus 4, which is equal to 19. So 4 plus 3 plus 8 plus 4. Now my dear students, instead of doing the multiplication, let me tell you. Here if I have taken 36 degree, okay. Here 30 degrees are added, and here if you take 30 degrees were added here also. So 4 times, 4 plus 4, 8 times, there is a 30 degrees extra value. In 8 times, there is a 30 degrees less value. If you do the calculation, I'm just telling the calculation values. If you do the ordinary using the calculator, you can get a value of 36 degrees, 0, 0. What I am trying to say is 30 minutes is extra for 36 degree 4 times, and 30 minutes is extra for 4 times. 4 plus 4, 8 times. Anyhow, 8 times they have reduced 30 minutes below 36. So the average will be 36 degrees. So how to calculate the most probable value is number of observations multiplied by the observed value divided by the total number of observation will give you the most probable value. I hope this solution is clear for you. So let us move on to the next question. Okay, so see students, before going to this question, let me tell you some basics of surveying. So let me tell you some basics of the surveying, students. So when I talk about surveying, see students, when I talk about surveying, we have some basics. What is the basic principle of surveying? So my dear students, the first principle of surveying is working from whole to part. See my dear students, the first principle of surveying is nothing but working from whole to part. Okay, working from whole to part is the first principle of surveying. Now immediately your friend might ask me, sir, why the principle of surveying is work whole to part? Why it is not part to whole? The reason is simple, Amma. If you work from whole to part, means the total area is fixed and you are coming to the part. That means here errors will not be accumulated or errors will not be increased. If it is part to whole, the errors will be increased. So that is the first reason. The second one point is locating a point. The second principle of surveying is locating a point with respect to two known points. What, my dear students? Locating a point with respect to two known points. Respecting a point with respect to two known points. So here let me tell you, see students, suppose we have 2 points A and B here, and we have joined this line, and if you want to locate a point C, now here you have to drop a perpendicular and you have to locate this. Or if you have 2 points A and B, draw an inclined angle here and draw an inclined angle here. They meet at point C. So this is the basis of principles of surveying. So the principle of surveying is working from whole to part where areas will not be accumulated, and next one is the locating a point with respect to two known points. Now let me tell you the applications. So what are the applications? See students, the first application is if you want to locate a point, whether it is above the datum or below a datum. What is a datum means? It is a reference line to measure whether it is above the datum or below the datum. For simple example, datum can be a mean sea level. So to determine the relative position of a point with respect to the datum, you can know using the survey. Other application can be to find out objectives of surveying. The other objective can be finding out the area, volumes and all, or to determine the relative positions of any other points with respect to the known points. These are the objectives of surveying, my dear student. Now let me tell you, based on the applications, we have different types of surveying. So if you want to know a control point, what is a control point, my dear students? A control point is nothing but a known point, my dear students. So to find out the control points, the Survey of India has been establishing this control, whether it can be a horizontal control point or whether it can be a vertical control point. Now, my dear students, when you talk about hydrographic surveying is a surveying where it was done on the water bodies. So, my dear students, based on the revenue people, if you want to understand what is a cadastral survey, to find out the plot area or to find the extremities of a plot, this was done by a revenue engineer, and this surveying is known as cadastral surveying. If you are doing some surveying in Himachal Pradesh or Uttarakhand, there the hilly areas are more, this type of surveying is done on natural features such as hills or mountains. This surveying we call it as topographic survey. And my dear students, you can do the underground works such as railway, underground works for mines and all. This kind of surveying is called underground surveying. And my dear students, to find the astronomical observations, we call it as astronomical survey. So we have different types of surveying. So we have different types of surveying, students. So we have different types of surveyings. What are the different types of surveyings? One is cadastral, topographic, hydrographic, or you can say control surveying. Now, my dear students, let me tell you what is the basic difference between a plan and a map. As a survey engineer, you should understand what is the difference between a plan and a map. My dear students, I will give you a simple example. For a building design, you have a plan. For a town or for a village or for an urban city like Bangalore, we have the map. Map is a place where you will get all the features. And remember, if you talk about the plan, for a building design, we usually call plan because they are drawn relatively large scale. So you can identify the features in more detail in a plan, whereas if you talk about a map, it is confined to a larger area, the scale will be very less. To identify the features, it will be very precise and very less, okay, to view. That's what I want to tell you, what is the basic difference between a plan and a map. Now, my dear students, we have shrinkage factor. We have a concept called shrinkage factor. Now, my dear students, let me explain you what do you mean by shrinkage. Now, what do you mean by shrinkage, my dear students? If you have a cotton cloth, right? If the cotton cloth is immersed in water, what do you sense it? The cotton cloth gets shrunk. That is called shrinkage. And remember, my dear students, the shrunk length will be always less than the actual length. So here shrinkage factor, if I write shrinkage factor as SF, shrinkage factor is defined as the ratio of shrunk length upon, shrinkage factor is defined as the ratio of shrunk length upon actual length. What, my dear students? Shrinkage factor is defined as the ratio of shrunk length upon actual length. And my dear students, let me tell you, here shrunk length is always less than the actual length. Hence, shrinkage factor is always less than 1. This is a very important observation because shrinkage is nothing but the reduction in length. So, if you talk about the actual area, if they ask you what is corrected area, formula, my dear students, corrected area can be taken as measured area upon shrinkage factor whole square. Now you can ask me here, student, sir, why you have multiplied the shrinkage factor twice? My dear students, the logic is simple. In area, we find the dimensions in two ways, in lengthwise as well as widthwise. So that is the reason shrinkage factor in length multiplied by shrinkage factor in width, you will get shrinkage factor whole square. And see here, students, if they ask you what is corrected length, here if they ask you what is corrected length is nothing but measured length upon, you can write corrected length is equal to measured length upon shrinkage factor. And remember, if they ask you what is original scale, then, what is shrunk scale, if they ask you, original scale multiplied by shrinkage factor. Are you getting, my dear students? If they ask you what is shrunk scale is nothing but original scale into original scale multiplied by the shrinkage factor. So, my dear students, when you solve these kind of These kind of means whenever you are solving the problems, all these formulas will be helpful in solving the problem. So we'll go into the problem and I'll give you 1 minute of time. Please read the question here and solve the problem, my dear students. Now see students, here they have given you the actual, they are asking you the actual area in meter square. For your information students, they are asking the actual area in meter square. Now what I would like to tell you here is, the plane of a survey plotted to a scale of 10 meter to 1 centimeter is reduced in such a way that a line originally 10 centimeter long now measures 9 centimeter. The measured area is how much, sir? 81 centimeter square. Now see, here they have given in the problem the measured area is, in the problem they have given measured area is equal to how much, students? They have given in the problem measured area is equal to 81 centimeter square. And remember, my dear students, here a 10 centimeter line, a 10 centimeter line measures, a 10 centimeter line measures 9 centimeter. What, sir? A 10 centimeter line now measures 9 centimeters. So what does this indicates is, 9 centimeters indicates shrunk length and 10 centimeter line indicates original length. So my dear students, here shrinkage factor is given by the formula, shrinkage factor is given by the formula, shrunk length upon, shrinkage factor is given by the formula, shrunk length upon actual length. Shrinkage factor is given by the formula, shrunk length upon actual length. So here if I talk about the shrunk length here, shrunk length is given as 9 centimeter divided by actual length is 10. So this value will be equal to 0.9. So what is the shrinkage factor here? Shrinkage factor is nothing but 0.9. Now my dear students, if I talk about the corrected area is given by corrected area. Okay, see students, here corrected area is given by the formula. Corrected area is given by the formula measured area upon shrinkage factor whole square. So whenever they have given you clearly the measured area is 81 centimeter square. So my dear students, here measured area is 81 centimeter square upon shrinkage factor is 0.9 whole square. So if you consider here, this will be equal to 100 centimeter square. But the problem is not done for your information, my dear students. Now the corrected area is 100 centimeter square. It doesn't mean that the problem is done, because he has given that 1 centimeter is equal to 10 meter according to the scale, and he want the answer to be in meter square. So here, if you know 1 centimeter is 10 meter square, 100 into 10 meter whole square. See students, this will be equal to 10 power 4 meter square or 10,000 meter square. See my dear students, here they have given you, it is to a scale of 10 meter to 1 centimeter. Please underline this. And he has asked in the final answer, I want the actual area to be delivered in meter square. So my dear students, here I have calculated the corrected area as measured area upon shrinkage factor whole square. Measured area is nothing but 81 centimeter square divided by the shrinkage factor square. You will get a value of 100 centimeter square. But as the answer was asked in meter square, they have given the scale as 1 centimeter as 10 meter. Just plug in that value 10 meter whole square here. You will get a value of 10 power meter square. I hope this solution is clear for you. Now we have another beautiful question, students. I want everyone to solve this problem. First go through the question carefully and we will solve the problem. Now see students, before solving these problems, let me tell you some important formulas for corrections. Now see students, we have different formulas for corrections of a tape, okay. When I talk for the corrections, the first correction is nothing but the correction for standardization. First correction is what, sir? Correction for standardization. Now correction for standardization is given by the formula L into CA, correction for each length upon length of the tape or standard length. So this is the formula. Now let me tell you, my dear students, the correction for standard, sir, video is not visible. One second, students. Can you see the video now? Students, can you see the video? Sai Srujana? Can you see the video now, Srujana? Can you please comment? Very good. Thank you. Thank you for letting me know, Amma. So see students, here correction for standardization is given by the formula what, sir? It is given by the formula CA into L upon small l. So what is L means? The standard length of the chain or a tape. What is capital L means? It is the total length measured. and CA is the standard length, means it is the correction for standard length. And remember my dear students, here this correction can be positive or this correction can be negative. If the chain is too long or if the chain is too short, based on that. Suppose if the chain is too long, see students, if the chain is too long, the measured distance will be less and the error will be negative and correction will be positive. If the chain is too short, the measured distance will be more, error will be positive, correction will be negative. So based on whether the chain is long or short, correction for standard deviation is given. And you know my dear students, correction for slope. Correction for slope is always negative. Are you getting my dear students? Correction for slope is always negative. Why the correction for slope is always negative, my dear students? Suppose if you are measuring some line here, okay, it is inclined and we have a horizontal line here. So for the inclined line, for this inclined line, the inclined line length will be always greater than the horizontal distance. So here correction for slope is given by the formula L into 1 minus cos theta. Correction for slope is given by the formula L into 1 minus cos theta, where theta is the inclination. Or if I consider this as H, correction for slope approximate formula can be written as H square upon 2L, or you can write it as L minus root over L square minus H square. Okay, sir, if this is L, if you want to this length, what you will do? L can be written as root over L square minus H square. So remember students, the correction for slope has three formulas. One is the L into 1 minus cos theta, other one is H square by 2L is the approximate formula. This is capital L, H is the elevation from the ground. And here we have the small l can be written as L minus L can be written as L minus root over L square minus H square. So these are the formulas for correction for slope. Now let me tell you. Next one we have is correction for temperature. Correction for temperature. Now you might be knowing this students. You might be knowing this L alpha delta T. So you know what is the change in length when there is an increase in temperature or decrease in temperature. Change in length can be written as L alpha delta T. The same formula here I will be applying. You can write correction for temperature, my dear students. Correction for temperature can be taken as L into alpha into Tm minus T naught. What, my dear students? Correction for temperature is given by the L alpha into T minus T naught. Here alpha is the coefficient of thermal expansion. What is alpha? Alpha is the coefficient of thermal expansion. And remember my dear students, it was given always in the units of per degree Celsius. The coefficient of thermal expansion is always given in the values of per degree Celsius. And what is Tm? Tm is the temperature during the measurement. T naught is the standard temperature. So my dear students, correction for temperature is positive when Tm is greater than T naught. When Tm is greater than T naught, correction for temperature is positive. And remember, correction for temperature is negative. Correction for temperature is negative when Tm is less than T naught. So here you should be very careful. Tm greater than T naught, correction for temperature is positive. Tm less than T naught, correction for temperature is negative. Similarly, my dear students, we have correction for pull also. So if they ask you what should be the correction for temperature, means it can be a cumulative, it can be a positive or it can be a negative. But when you talk about correction for slope is always negative, my dear students, which is a very important point. Now, when I talk about correction for pull is given by the formula P minus P naught into L upon AE. P minus P naught into L upon AE. So here, if P is greater than P naught, correction for pull is positive. What is P naught? P naught is the standard pull and P is the applied pull, my dear students. And here if P is less than P naught, correction for pull is negative. Am I clear, my dear students? So these are the corrections for pull and correction for temperature. Now we have the another important correction for misalignment. Misalignment means here instead of measuring like this, you will be measuring with an angle theta 1 and with an angle theta 2. So this is simple, amma. You have to apply the slope corrections twice. So with different lengths. So correction for misalignment, if I talk about correction for misalignment will be always negative, which is equal to correction for slope for this line is L1 into 1 minus cos theta 1 plus L2 into 1 minus cos theta 2. So these are the formulas for correction for correction for misalignment. Okay. Now we have very important thing, my dear students. The important concept we have is the correction for sag. Correction for sag is always negative. Correction for sag is always, remember my dear students, correction for sag is always negative. Agree or not? Now see, suppose if I have tower like this. This is the transmission towers and all. Okay, here if you have the transmission towers, suppose if the current wires are connected like this, after some time they get sagged like this. And correction for sag formula is given by the formula W square up L upon 24 N square P square, where W is the weight of the tape, L is the total length, N is the number of bays. Here we have 1 bay and here 2 is the P. P is the applied pull. Similarly, correction for mean sea level is also there, student. Correction for mean sea level. If it is above the sea level, you will get correction as negative. Below sea level, correction will be positive. And the formula is LH upon R, where R is the radius of the earth, H is the height above the surface of the earth, or it can be below. Above it will be negative, below it can be positive. So these are all the important corrections, my dear students. So let me solve the problem here. So here they have given the total length measured is how much, students? Here total length measured is 285.5 meter. Total length measured is how much, sir? 285.5 meter. Now it is short by 0.05 meter. It is short. So here see, students, it is short by how much, sir? 0.05 meter. It was short. So see, students, actually if you consider 30 meter and 30 meter minus 0.05, this will be equal to 29.95 meter. This will be equal to how much, sir? 29.95 meter. Okay. Now how to calculate the corrected length with respect to the standardization? So corrected length, what? Corrected length is how much, sir? Is equal to, you can, I told you corrected for standardization, it is short. Short means measured length will be more. And you know measured length is more means error is positive and correction will be negative. So you got 29.95 divided by 30 into 285.5. This will be giving you 285.5.024 meter. So you will get a value for correction for standardization is 285.4024 meter. Now see, students, this was laid on a slope. This was laid on a slope. Now see, student, correction for slope they have given. Now correction for slope is given by the formula. As I told you, approximate formula is given by the formula h square upon 2l. And see, correction for slope they have given as 1 by 10 is equal to h by l is 285.5024 meter. So h will be equal to 28.5024 meter. So correction for slope, you know the h value. Okay. See, students, if you don't know this, tan theta is equal to 1 by 10. cos theta you find out, or L into 1 minus cos theta is nothing but you will get the answer. After that you have to remove that value. So H square is how much, sir? 28.5024 square upon L is how much, sir? 285.024 meter. So if you solve this, you will get around 1.724 meter. How much, sir? You will get 1.724 meter. And remember, correction for slope is always negative. So the corrected length, if you see, corrected length is equal to 285.50.24 minus 1.724 will give you how much, sir? 283.6 meter. So the final answer we have is how much, sir? 283.6 meter. So if you see the solution here, what is the answer we have? 283.6. So the option A will be the correct answer. I hope this solution is clear. Now see students, first we have to find out it is a short. So it is short by how much, sir? 0.05 meter. So 30 minus 0.5, you will get 29.95 into 30 divided by standard length. You will get the answer. After that, it was laid on a slope. We have corrected the correction for slope. And correction for slope is always negative. So we have removed that value and we got 283.6 meter. I hope the solution is clear. Now please solve this problem. This is a simple problem, students. Okay, see students, here see, the question is simple, my dear students. The direct and reverse zenith angles are observed as 57 degrees and 303 degree. Now see students, if we consider here, they have given one angle as how much, sir? 303 degree. Okay, another angle they have given as 56 degree. Okay, another angle they have given as 56 degree. So see students, what we have to do here is, what is the vertical collimation error? So if you see here, if you talk about the vertical collimation error, it is given by the formula phi1 plus phi2 minus 360 degrees upon 2. So here phi1 value is how much, sir? 56 degree, which is given in the problem. Phi2 value is given as 303 degree minus 360 divided by 2. This value will be equal to 1 degree divided by 2. So it is minus 30 minutes. So the answer here is minus 30 minutes. So option C will be the correct answer. So here whenever they have given you direct and reverse zenith angles, the formula is, the vertical collimation correction is given by the formula phi1 plus phi2 minus 30, 360 into, this is error, sir, actually. Sorry students, this is error actually. We got minus 30 minutes as the error, but they have asked you the correction. So correction will be a vice versa. So it will be equal to 30 minutes. So the answer here will be option D. So remember students, you should be careful when you are solving these kind. Error and correction are always vice versa. Okay. Now see, solves these questions, student. Now see students, let me tell you one important thing here before going to compass surveying. Sir, what do you mean by compass surveying? Let me tell you quickly. What do you mean by compass surveying? My dear students, a compass surveying is a branch of surveying in which it is a branch. Compass surveying is a branch of surveying. Compass surveying is a branch of surveying. Compass surveying is a branch of surveying in which the direction of the directions are determined with the help of a compass. Okay, see students, let me tell you, we have two systems, students. You already know this. One is the whole circle bearing system. We have whole circle bearing system. So see students, if I consider this as a whole circle bearing, okay, if we consider this as that 4 lines. Now, before I am talking about whole circle bearing system, students, there is a meridian. What is a meridian means? In coordinate system, we have origin. Everything is measured with respect to origin. Similarly, what is a meridian means? It is a fixed line of reference about which the angles are measured. Bearing means it is the angle between the meridian and the survey line is known as bearing. We have different types of bearings like true meridian, magnetic bearing, different types of bearing like true bearing, magnetic bearing, arbitrary bearing and grid bearing. So, if it is with respect to true meridian, a line joining true north and south is true meridian. If it is with respect to magnetic meridian, then it is called magnetic bearing, a line joining magnetic north and magnetic south. What is grid bearing means? Area is divided into grids and the central portion will be taken as a reference. That is called a grid meridian. Arbitrary meridian means according to your convenience, you take some arbitrary or a prominent mark as the reference. That is called arbitrary meridian. So here see students, if you talk about whole circle bearing, this is north, this is south, this is east and this is west we have. And here see students, now we have this is theta 1, this is theta 2, this is theta 3 and we have this is the theta 4. Now what you have observed in whole circle bearing is the bearing of any line is measured with respect to north only and also in clockwise direction. So remember students, in whole circle bearing system, bearing of any line is measured with respect to north and in clockwise system. Here the angle varies from 0 to 360 degrees. Whole circle bearing system is also known as azimuthal system. This is very important, students. In some questions they can ask you, what is the azimuth of the whole circle bearing is also known as what, students? Whole circle bearing is also known as azimuthal system. What is whole circle bearing? Whole circle bearing is also known as what, my dear students? It is also known as azimuthal system. Okay. So this is what all about the whole circle bearing. Now my dear students, let me show you reduced bearing. We have another concept called reduced bearing. Okay. Now see students, what do you mean by reduced bearing? Let me tell you. What do you mean by reduced bearing? Suppose see students, if I consider this as two lines, here we have, this is north, this is south, this is east and this is west. And remember see students, here we have the survey lines 1, 2, 3 and this is 3. Now if I consider this as O, this will be A, B, C and D. And you can take these values as alpha, this one is beta this one is gamma, and this one I will take it as delta. So what you have observed here is, what is reduced bearing? Remember, see students, reduced bearing is also known as quadral bearing. What is reduced bearing, sir? Reduced bearing is also known as quadral bearing. Here please remember students, reduced bearing is also known as quadral bearing. Now see students, what do you mean by reduced bearing is, it is the bearing of a line, it is the bearing of a line measured either from north or from south, in clockwise or anti-clockwise, whichever is nearer. You can say bearing of a line is measured from north or south. Bearing of a line is measured from north or south. It is measured from north or south, clockwise or anti-clockwise. It can be clockwise or also it can be anti-clockwise, whichever is nearer. Agree? So it can be, this is a very important student. Reduced bearing you can measure either north or south, but whichever is nearer, and also in clockwise or anti-clockwise. And here surveyor compass is calibrated with this system. So this is all about the difference between the reduced bearing and the whole circle bearing or azimuthal system. Now see students, we also have another point called fore bearing, which is very important, sir. We have another point called fore bearing. Sir, what do you mean by fore bearing is the bearing which is in the direction of the survey. This, if I consider this as fore bearing, the bearing in the direction of survey is known as fore bearing. You can write here students, fore bearing means bearing in the direction of survey line is known as what, sir? Fore bearing. Similarly, what do you mean by back bearing? Okay, if I consider this as a survey line, what do you mean by back bearing is, this is known as back bearing. Back bearing means it is the bearing, back bearing is the bearing which is opposite to the direction of survey. Okay students, so this is all about the back bearing and fore bearing. So let us start the problem. We have done this problem. Now see students, he is asking the magnetic bearing of a sun for a location is 180 degree 30 minutes. If the sun is exactly on the geographic meridian at noon, what is that? Okay. Now see students, he has given in the problem magnetic bearing is equal to what, sir? 183 degree. Magnetic bearing is equal to 183 degree 30 minutes. Okay. Now see students, magnetic declination is defined as the difference between, true bearing and magnetic declination is defined as the difference between true bearing and magnetic bearing. The difference between true bearing and magnetic bearing. The difference between true bearing and magnetic bearing is nothing but magnetic declination. Now see students, if the declination is positive, if the declination is positive, if the declination is towards eastwards, if the declination is towards eastwards, we take it as positive. And here if the declination is westwards, we take it as negative. I am just giving you the insight also, students. So see students, magnetic bearing is 180 degree, 183 degree, 30 minutes. But he has told true bearing is at noon. At exactly at noon, if you see, the true bearing is equal to 180 degrees. Okay. Now what do you mean by declination? I told you, declination is the difference between true bearing minus magnetic bearing. True bearing is 180 degrees minus magnetic bearing is 183 degree, 30 minutes. So this value will be equal to minus 3 degree, 30 minutes. So I told you already, minus indicates what, sir? Westwards. So the answer here is minus 3 degree, 30 minutes west. So the option A is the correct answer. I hope this solution will help you. Okay. Please solve this problem. It's a easy problem, but there is a small thing here. Just I want to tell you that. Please solve that problem. Now see students, I have given you enough time. Here he is asking what is the azimuth observed. So if you see here, sir, if you see the angle is given as how much, sir? North 31 degree, north 31 degree, 17 minutes west. So if you see students, how to identify whether it is a reduced or a whether it is a quadral bearing. If they give you the convention, see students, if you see here, the reduced bearing angle is given as this is north and this is west. So this angle is given as 31 degree, 17 minutes. But what you have to get this value? This is whole circle bearing. So whole circle bearing here can be written as 360 degree minus, or if they ask you azimuth also says that it is whole circle bearing. I told you 31 degree, 17 minutes. So if you solve this, how much, sir? 328 degree, 31 means 328, 59, 328 degree, 43 minutes. So the answer here is how much, sir? 328 degree, 43 minutes. But they asked you in minutes, sir. So remember students, 1 degree is equal to 60 minutes. So 43 minutes is equal to how many degrees means? 43 by 60. It will be 0.7, okay, 0.72 or something. You can write 0.72 degree. So this answer will be equal to 328 degree, 328.72 degree. You can write here 328 degree, 43 minutes, right? You can write 328.78 degree. So actually in the ordinary calculator, you know how to convert degrees into minutes and all. But with the virtual calculator, you don't have that option. So I was telling you. So I hope, because they asked in the blank, they have given you in degrees. Now see students, it is also a similar question which I have told you. What is this question is, if the magnetic bearing of the sun at a place is south 2 degree east. Sir, see here, I told you already, see students, magnetic bearing, I told you already, magnetic declination is equal to, or magnetic declination, or you can say, you can write declination, sir, directly. You can write declination is equal to declination is equal to true bearing minus magnetic bearing. What's sir? Declination is equal to true bearing minus magnetic bearing. Here true bearing is given by the formula. We have to don't know the true bearing. They have given it is sun, right? So true bearing at noon, I told you just now, true bearing at sun at noon is 180 degrees. Magnetic bearing is how much, sir? It is given as south to 2 degree east. So south to 2 degree east means if we consider here the bearing, here if you see this is a line, this is equal to, this is south and this is east. This is 2 degree. So this value will be equal to 178 degree. So if we convert into whole circle bearing, this value is equal to how much, sir? 178 degrees. So magnetic declination D is equal to true bearing is 180 degrees minus magnetic bearing is 178 degrees. So it is 2 degrees. So it is positive value. So you can say 2 degrees east. So the option A is absolutely correct answer. Okay. Now please solve this problem, students. I will give you 2 minutes of time. Now see students, it's a beautiful question here. See students, actually this question was asked so many times, students, in GATE exams and also IES and all. Now my dear students, let me tell you what is a well-conditioned triangle. What is a well-conditioned triangle is, see, well-conditioned triangle means if theta is greater than 30 degrees, if theta is greater than 30 degrees and theta should be less than 120 degrees. These are the conditions. If you see in a triangle, if theta should be greater than 30 and theta is less than 120, then it is a well-conditioned triangle. And remember my dear students, the best well-conditioned triangle is nothing but the equilateral triangle. The best well-conditioned triangle is how much, sir? The best well-conditioned triangle is nothing but equilateral. The best well-conditioned triangle is nothing but the equilateral triangle. Okay. The best well-conditioned triangle is nothing but what, students? It is nothing but the equilateral triangle. Now, what is an ill-conditioned triangle? If theta is less than 30 degrees and if theta is greater than 120 degrees, this indicates it's a ill-conditioned triangle. This indicates what, sir? It is a ill-conditioned triangle. Okay, here see students, here if you see option Q, we have 25 degree. See here students, when I see the triangle Q, it has a value of 25 degrees. which is less than 30 degrees. And here if you see all are set, here also it is less than 30 degrees. So he is asking which of the following triangles are ill-conditioned triangle and should be avoided in triangulation survey. So you can say Q and S. So option D is correct, students. So both Q and S are wrong. Ill-conditioned triangles. Now see, students, the stations which are mostly affected by the local attraction. Now let me tell you another important thing here. Now see, students, what do you mean by local attraction? Now see, students, what do you mean by local? What do you mean by local attraction here? Local attraction means, see here, what do you mean by local attraction is, see, students, if back bearing minus fore bearing is equal to 180 degrees. Suppose there are two stations, sir. If back bearing minus fore bearing is equal to 180 degrees, then remember, students, no station is affected by local attraction. No station is affected by local attraction. No station is affected by local attraction. If back bearing minus fore bearing is equal to 180 degrees, then no station is affected by local attraction. Next, if back bearing minus fore bearing is not equal to 180 degrees, if back bearing minus fore bearing is not equal to 180 degrees, if there are two stations, for suppose A and B, only station A can affect. Only station A can affect. Only station A can affect. Or C, students, only station B can affect. Only station B can affect. So there can be various cases. Okay, see, students, are you observing or not? Or you can say both stations can affect. Both can affect. So when back bearing minus fore bearing is equal to 180, there is no station is affected. If back bearing minus fore bearing is not equal to 180, station A can affect, station B can affect, or both stations A and B can affect. So there can be various possibilities of these three. Now let me go through this problem. Now see, students, here we have first, sir, see, students, let me tell you, if they give you PQ, okay, they give you PQ, and here they give you QP. Sir, if fore bearing is considered as PQ, back bearing, if you interchange the names, that will be back bearing. So if you see 226 minus 180, this is equal to 180 degrees. Okay, are you getting, my dear students? PQ indicates fore bearing of PQ. QP can be written as back bearing of PQ for your information. Now here if you see, this is not equal to 180 degrees. And if you see RS also, RS is also equal to 180 degree. Not equal, 180, right? 180 means 200. It is also not equal to 180 degrees. And if you consider ST, this is equal to 180 degrees. Are you getting, my dear students? If we consider C, students, let me tell you. See here, if I consider P and Q, there are four stations here, students. There are four stations here, P, Q, R, S and T. Now let me tell you, see, students, this is a very important observation. The difference between back bearing of QP and PQ is equal to 180 degrees. So it is evident that P and Q are not affected. Okay, sir. Now similarly, if you consider ST and TS, this is also equal to 180. So it is evident that S and T, these are also not affected. So which is the affected station only we have? What is the affected station only we have is R. The affected only station is what, sir? R. So station A is the only right answer. Clear, students? So you can mention here how to find out easily the local attraction problems. If back bearing minus forebearing is equal to 180 degrees, then it is no local attraction. Between any station, no station is affected. If it is not equal to 180, either station A can affect, station B can affect, or both the stations can affect. But with this logic, what I have done, just finding out the whether it is 180 or not. Just do that and take 5 stations. Out of that, 4 stations are not affected. So the only station affected is R. This is a beautiful problem, students. I will give you 2 minutes of time. Please solve this problem. Now see, students, here we have a question here. What is the question here is, in a region, the magnetic declination is how much, sir? Magnetic declination is 2 degrees east, and magnetic forebearing is how much, sir? Of a line AB was the north 79 degree 50 minutes. To determine the corrected bearing of the line, point O is measured. The magnetic forebearing of line AO and OA are measured. Now see, students, let me do this. The magnetic forebearing of a line AO and OA. Magnetic forebearing of line AO and magnetic forebearing of line OA. Let us see, sir. What is AO? AO is how much? South 50 degrees 40 minutes. South 50 degrees 52, right? South 52 degree 40 minutes. What is OA, sir? See, students, what is OA? North 50 degrees 20 minutes west. So it is north 50 degrees 20 minutes west. Now see, students, what they have done. South 20 degrees east, what is the forebearing of line AB? East, right? Now see, students, sir, there are 2 bearings here, magnetic forebearing of AO and OA. But what he has told is, whatever the reading which you are taking from O is correct. He has given O is free from local attraction. Station O is free from local attraction. See, students, when he is told that O is free from local attraction, for your information, whatever the forebearing of OA will be correct, sir. So OA is equal to how much, students? So what is OA? OA will be equal to north 50 degrees 20 minutes west. So if you consider here, this is north 50 degrees 20 minutes west, right? So if you convert into whole circle bearing, it will be equal to how much, sir? 309 degree 40 minutes. Now just now I told you, students, if the forebearing of OA is equal to this value, what will be the forebearing of AO? AO should be equal to 360 minus, sorry, we got how much, sir? It is equal to how much, sir? This is 309 degree 40 minutes. So 309 degree 40 minutes minus 180 degrees. Now how this formula came is, see, students, you know back bearing is equal to forebearing plus or minus 180 degrees. Plus sign is used when forebearing is less than 180. And negative sign is used when forebearing is greater than 180 degrees. Greater than how much, sir? Positive sign is used when forebearing is less than 180. Negative sign is used when forebearing is greater than 180. So here you can write back bearing is equal to how much, sir? Forebearing plus or minus 180 degrees. So here forebearing of AO can be written as 129 degree 40 minutes. Okay, this should be the actual value. But what is the value they have given here? Sir, what is the value they have given here? If you convert this into whole circle bearing, see students, if south 52 degree, okay, so this will be equal to, this is 52 degree 40 minutes. So this will be equal to 127 degree 20 minutes. But actually it should be 129 degree 40 minutes. So if you see the correction is, if you see the correction for local attraction is how much, sir? So the correction at A will be taken as positive 2 degree 20 minutes. Okay. Now see students. See, magnetic forebearing of a line AB is equal to north 79 degrees 50 minutes east. Okay, now see students, true bearing of AB can be written as, remember students, true bearing of AB can be written as 2 degrees east. Now, magnetic bearing of AB plus declination. Why plus, sir? Because the declination is towards eastwards, and plus the correction at station A, plus the correction at station A due to local attraction. This is due to the local attraction. Now, my dear students, what is the value at AB, sir? Magnetic bearing of AB is 79 degree 50 minutes plus declination is how much, sir? 2 degrees, and this value is 2 degrees 20 minutes. So this value is equal to, so if I take here 2 degree means 80 degree 10 minute, you can write 84 degrees 10 minutes. Sir, if it is a first quadrant, usually we don't need to show as northeast, we can directly write as 84 degrees 10 minutes. That itself indicates it is a first quadrant. So you can write here 84 degrees 10 minutes. So the option C is correct, sir. So the option C is correct. Now please solve this question, students. Please solve this question. Okay, see students, let me tell you the question here. A traversing is carried out and the internal angles at vertices PQRS are 92 degree, 68 degree, 123 degree and 77 degree. Now, angle at PQRS. What are the angles they have given, students? They have given as 92, 68, 92, 68 degrees, 123 degree. Another one we have is how much, sir? 77 degree. Now see students, if you consider a line PQ here and see PQ is how much, sir? 27 degree, forebearing of line PQ. But what he is asking, what is the forebearing of RS? What is the forebearing of RS? Okay, now see students, but what is the, this is P, right? Next we have another point is here, what, sir? Q. But what is the angle of Q here? This is first quadrant. Q angle is how much, students? It is 68 degree. Sir, if it is in first quadrant, it will be more than 90 degrees. Yes or no, students? Yes or no? So here if I draw a line here, this angle is equal to how much, sir? 68 degree, which is given in the problem, Q. So this is Q and we have this is R. Okay, now what is the angle of S, student? Angle of R. R is given as 123 degree. Yes or no? Because he is asking this is QR. QR angle is how much, sir? This is, because this value will be equal to how much, students? This is equal to 68 degree. Agree or not? Now, what is the angle of R? Suppose if I draw like this, I am assuming this is S. Okay? Because we have to know the forebearing of RS only, this angle. Okay, now see students, how, just assuming this point, student. Now, what is forebearing of PQ? Forebearing of PQ is equal to 27 degree. Now see students, how to find out forebearing of QR. Now my dear students, what is back bearing of PQ, amma? Back bearing of PQ is equal to 27 plus 180. 27 plus 180 is equal to how much, sir? This is equal to 207 degrees. Back bearing of PQ is equal to how much? 207 degrees. Because it is 27 plus 180, it is equal to how much? Back bearing of PQ is 207 degrees. Now you know this is back bearing of PQ. This is a 207 degrees. So you can write forebearing of QR is equal to back bearing of PQ minus angle Q. So back bearing of PQ is how much, sir? How much it is? PQ is 207 degrees minus, what is this value? 68 degree. So this will be equal to 139 degrees. So this is how much, sir? So QR is 139 degrees. Now see student, if you take here, if you take QR, now we got forebearing of QR. Now back bearing of QR is how much, sir? Back bearing of QR will be equal to 139 plus 180. So this will be equal to 319 degrees. Yes or no? Now see students, he is asking what is the forebearing of RS. So back bearing of QR is how much? 390 degrees. Angle R is equal to how much, sir? Angle R is equal to 123 degree. Angle R is 123 degree. So back bearing of QR is how much, sir? 329 degrees. Yes or no? So 329 degree, sorry, 319 degree. So the angle is, so forebearing of RS will be equal to 319 minus 123 degree. So what is this value, students? 390 minus 123 degree. It will be equal to 180. It will be equal to how much, sir? 196 degree. So forebearing of RS is equal to 196 degree. Please check this, students. So what is the forebearing of RS? It is equal to 196 degree. You can write forebearing of RS is 196 degree. Okay. Agree? Is this clear, students? So remember, see students, what I would like to tell you here, one point is, suppose if you consider this as some angle, suppose if I consider this as forebearing and back bearing. Now see students, if this is forebearing of PQ, suppose if you have taken PQR itself. Now if I take this as angle Q, how do you find out angle Q here is, angle Q can be written as back bearing of preceding line, that is PQ. Remember, this will help you a lot in solving the problems. Back bearing of preceding line minus forebearing of succeeding line. Interior angle can be written as back bearing of preceding line minus forebearing of succeeding. So angle Q can be written as back bearing of preceding line minus forebearing of succeeding line. Is this clear, students? Is this clear, Amma? So let us go into the next problem. So this is another important problem, students. I'll give you a timer here. Please solve this problem. Now see, students, we have one concept here. Now please see, students, suppose this is a traversing line here. We have here, if we have a traversing line here, okay, if this is theta, if this is theta and this is L, this line is L, this we call it as latitude, sir. Latitude is equal to L cos theta, and here we have departure, D is equal to L sin theta. Now here I am just giving you the hint, sir. In a closed traverse, in a closed traverse, in a closed traverse, in a closed traverse, sum of latitudes is equal to 0, comma, sum of the departures is equal to 0. In a closed traverse, what we have? Sum of latitudes is equal to 0 and sum of departure is equal to 0. And the closing error is given by the formula sum of latitude square plus sum of departure square. If they ask you what is relative closing error, this is E. Relative closing error is given by the formula. Relative closing error is equal to E upon P, where E indicates the error and P indicates the perimeter. Okay, now see, students, whenever this kind of problem is asked, whenever this kind of problem is asked, sir, see, what I would like to tell you is, usually what I would like to tell you is, northings positive, south negative. We take in, these are comes under latitudes. If you talk about departure, easting positive, westing negative. Okay, these comes under for departure. So northing, sir, vertical lines will be latitude and horizontal line will be departure. Northing will be positive, southing will be negative. So here if I take the southing values, what is the summation of southing values if you consider here? You get how much, sir? 196 point or 195, 196.1. I'm just, for your information, I'm writing here. If you take the eastings values, it will be equal to 101 here, sum of eastings. And if you take the sum of westings, it will be equal to 130.9. Okay. Similarly, if you take here, what is this value, sir? 190.8. So, sum of northings is 190.8, sum of southings is 196.1, 195, 196.1, and sum of eastings is 101, and sum of westings is 130.9. Now, see students, let me tell you here. Now, if you want to find out, sum of the latitudes can be written as sum of northings minus sum of southings. Okay, what is the sum of the northing value? 190.8, 190.8, and sum of southings values is how much, sir? 196.1 meter. So, sum of the latitudes is equal to minus 5.3 meter. Okay. Similarly, sum of departures can be taken as sum of eastings minus sum of westings. Sum of departures can be written as what, my dear students? Sum of easting minus sum of westings. So here, what is sum of eastings, sir? 101, and sum of westings is 130.9. So 101 minus 130.9, which is equal to 29.9 meter. 29.9 meter. So this is the values for sum of latitudes and sum of departure. Now what he is asking, if the station P is having 400 meter, if the station P is having 400 meter, comma 200 meter, it's a closed traverse. Sir, see, P, Q, R, S and T. Now they can ask you only for T. If you know these values, directly you can subtract that. Okay. So whatever, see here, you can write the coordinates of T is equal to 400 plus sum of latitudes minus 200 plus sum of departure. So what is here? Latitudes is, because 400 is northing, right? He has given 400 meter. Okay, northings and eastings only he has told. So this is northing, this is easting. So 400 minus 5.3, comma 200 minus 29.19. So this value will be equal to 394.7 meter, comma 170.1 meter. So these are the values. These are the values, see students. Okay, please write down that value, students. So if you have a multiple choice question, so the answer is 194.7 and 370.1. No, sorry, sorry. Not this one, sir. How much we have? 394.7 and 170.1. Option D is the correct answer. Now please solve this question, students. Please solve this question, students. let me check this answer. So see students, the following details are given. The length and direction of the length and direction they are asking of a whole circle bearing respectively. Now see students, here as I told you, sum of, if you consider here, what will be the sum of the northings, sir? Sum of northings is equal to 101 plus 419, that is equal to 520 meter. Okay, if this is in meter. Similarly, what is sum of southings, sir? Sum of southings is equal to 437 plus 83, that is equal to 520 meter. So this is equal to 520 meter and this is equal to 520 meter. Now what is sum of eastings? Sum of eastings is equal to 173 plus 558. You can write easting is equal to 173 plus 558. So this will be equal to 560, 631. So this will be equal to 731 meter. Okay. Similarly, sum of northings is, sum of westings is equal to what, sir? 96 plus 634. This will be equal to 730 meter. Now my dear students, sum of north departures, if I talk, sum of latitudes is equal to sum of northings minus sum of southings, that is equal to 520 minus 520, that is equal to 0. Yes or no? Similarly what, sir? Similarly we have sum of eastings minus sum of westings. Sum of eastings minus sum of westings, that is sum of departure. Agree students? Sum of eastings is how much, students? Sum of eastings is 731. Agree? So here we have 731 minus 730, that is equal to 1. This is also positive, this is also positive. Right students? So first is asking what is the length and direction of closure. Now see, error of closure is equal to, I told you already, error of closure is nothing but, please write down here, error of closure is what, students? Sum of latitude whole square plus sum of departure square. What, sir? Sum of latitude square plus sum of departure square is nothing but the error of closure. So here what is the error of closure? Here is sum of the latitude square is how much, students? It is sum of latitude square is 0 plus sum of departure square is 1 square. So it is equal to 1. Okay, theta is equal to what, sir? Bearing is asking. If they ask you bearing, bearing can be written as theta is equal to tan inverse of sigma d upon sigma L. Tan inverse of sigma d upon sigma L is what, sir? Bearing, which is equal to tan inverse of sigma d is how much, students? It is equal to 1. 1 upon 0, which is equal to infinity. Both are positive. So first it is first quadrant. See students, there is an important point here. If I consider here a latitude and departure both positive, first quadrant. Latitude negative, departure positive, then it is second quadrant. If both are negative, latitude, departure both negative, then it is third quadrant. If it is fourth quadrant, latitude will be positive and departure will be negative. So based on this, even though you get theta values at 30, 40, based on which quadrant you have to add these values. So this will help you to get the bearing values. Okay. Now let me go to the next question. Please solve this question, and very interesting question, students. friends, I have given you enough time. Now see students, what is the question here is the bearing of two inaccessible stations. One is 500 meter and another one is north 500 meter. And the bearing of S2 is 600 meter and 450 meter. From a station S3, the bearing of two inaccessible stations, S1 is how much sir? 500, 500. Another one is 600 and 450. So 600 meter easting and northing is 450. Are observed at an angle of 225 degrees from S3 and 153 degrees 26 minutes respectively. The independent coordinates of eastings of S3. Now let me draw the diagram sir. See here. What is the question here is we have a station S3 students. From this S3 station, one it is making an angle of how much sir? 225. So it is third quadrant. And other one is making how much students? This, if you take station, this S1. So here if you take S1 is making a station from a station S3 you are observed 225 degrees and 153 degree 26 minutes. So if I take this one is how much sir? 153 degree 26 minutes. Now see students, there is a two inaccessible stations. Here we have S1 and here we have S2. Now see students, if this angle is 225, what will be this angle sir? This is nothing but 4 bearing, so it will be equal to 45 degrees. Now similarly see students, if this is equal to 153 degrees, this will be equal to 26 degree 34 minutes, okay? Yes or no students? Now this is station S1 and this is station S2. So here it is having how much value sir? First one is having 500 northing and 500 easting. So here is telling 500 northing and 500 easting. Similarly, here it is having how much sir? S2 station is how much sir? S2 station has easting 450 and 600. 450 meter northing and 600 meter. This is northing and east. Now see students, what he is asking here is, he is asking what is the easting of coordinates S3. Now see students, the coordinates of S3, okay, in case of northing, for northing with respect to S1 and S2 will be same, right? Sir, see, there is some, I will tell you in a much simpler way, Amma. If it is x1, y1, sir, the coordinates of S3 with respect to x1, y1, you will write the coordinates of S3 with respect to x2, y2, right? Both will be same, right? So if I take this value as L1, this length, and if I take this length as L2. Now see students, please understand this. Here what I can write, this is northing norma. So this quadrant, this is 500 plus, what is this value sir? If it is latitude, what is this value? Upper latitude is L cos theta. So you can write L1 cos 45 degrees is equal to, what is this value sir? Northing 450 plus L2 cos, you can write here, or 450 plus is equal to 450 plus L2 cos 26 degree 34 minutes. 26 degree 34 minutes. Again I will write here. This will be equal to 26 degree 34 minutes. Okay. Now I have written northing sir. Similarly I can write easting also. What is easting amma? Easting can be written as with respect to S3. What is easting means this side. So you can write here 500 plus L1 sin 45. But here see, this is left side, so it should be negative. So is equal to how much easting? 600 minus L2. 600 minus L2. What sir? Sin 26 degree 34 minutes. Are you getting my dear students? We have here two equations. This is equation 1 and this is equation 2. Are you getting, my dear students? We have two equations, one is equation 1 and equation 2. If you see here, students, on solving those two equations, you will get L1 is equal to 70.71 and L2 is equal to, can anyone tell me what is, L1 is 70.71 and L2 what is the value, sir? If you see here, it is equal to 111.80, 111.80. But what is asking? What is the easting of S3? So he is asking only the easting. These are northings. So easting can be written as 500 plus. So easting can be written as, easting of S3 can be written as 500 plus L1 sin 45. So what is L1, students? 500 plus L1 is 70.71. Anyhow, you know sin 45 is nothing but 1 by root 2. If you remember, root 2 value is 1.414, and if you cancel this will be equal to 50. So the easting of S3 is 550 meter. So the answer, final answer for easting of S3 is how much? 550. Similarly, you can take northing value and you can solve the northing also. But in the problem, they have asked you only the easting. That is the reason I have done the easting only. Now see this problem, students. We have this problem. Please solve this. I'll give you 2 minutes of time. Please solve this problem, students. Read the question carefully, students, first. Now see, students, let me read this question. The question here is, an observer is standing on the deck of a sea, sees the top of a lighthouse. The top of the lighthouse is at 40 meter above the sea level and the height of the observer is 5 meter. What is the distance between this? See, students, actually, my dear students, see here, if you consider this as a line of sight, usually the level line will be like this, okay? Okay, we have some corrections like this, sir. Okay, one is we have the coefficient correction for curvature, and other one is correction for refraction. Okay. Correction for curvature is always negative, that is minus d square by 2r. And see, correction for refraction is 1 by 7 d square by 2r. If you see, students, combined correction we have, see, students, we have combined correction which is equal to minus 6 by 7 d square by 2r. So actually, see, students, usually there is a line here. This should be the line of slide, but it has been shown with this. This is called correction for curvature. Actually, the shape of the earth will be like this. But after some time, the line gets refracted. This is called coefficient of refraction. If you combine these two, then it is called combined correction. Now, in this problem, see, students, here we have a curvature. The height of the driver eye is 5 meter. This is how much? 40 meter. Agree, students? Okay, so here what I can write here is the combined correction D can be written as 3.854 into root H1 plus root H2. Are you getting, my dear students? Sir, am I audible? Okay. So here you can, instead of combined correction, you can use this formula directly. But remember, see, students, here H1 and H2 will be substituted in meters, but the answer you will be getting is in kilometers. That is an important thing. So 3.84 into root 5 plus 3.84 into root 40. So this will be, if you take 5 value, it will be 2.23. Root 40, if you take, it will be somewhere around 6.5 or some, like 6.4 or something. 8.6. If you solve this, you will get a value exactly 32.99 kilometer or 33 kilometer. So these kind of problems can be done using the combined correction concept. Clear, students? Now this is Simpson rule, sir. Here also staff held. 1 second, student. This is an important question, students. Please solve this question. Let me tell you here, what is the focal length of the object class of a tachometer is 200 mm. The distance between the vertical axis of the tachometer and the optical center is 100 mm. See, students, first let me tell you one important thing. Suppose if I consider this as a lens here and we have some concept like this, okay. If I consider this as the staff, so we can take F, if we consider this as the optical center O, and if we have the instrument, this is D, okay. So this is distance is D. So this is the focal length of the object F1 and F2 is the focal length of the stadia or eyepiece, you can write. F1 is the focal length of the object and F2 is the focal length of the eyepiece. So here if you see, the total distance D can be written as Ks plus C. Sir, horizontal, when the line of sight is horizontal, we can write the horizontal distance between the instrument and the staff is Ks plus C. Where K is this is called staff intercept and here I is called as stadia intercept, okay. Now see, students, here K is equal to multiplying constant is equal to focal length upon stadia intercept and additive constant is equal to focal length plus D, the distance from the center of the instrument to the optical center O, okay. So here see, students, here first of all they have given you, there are 3 intercepts, 1 meter, 2 meter and 3 meter, right. Now first we will find out the C, additive constant. Additive constant is how much, sir? Focal length plus D. So the focal length of the object is how much, sir? 200 meter, right. So this will be equal to 200 mm means what, sir? 0.2 meter. And see, the distance between the vertical axis of the tachometer and optical center is how much? 100 mm. So this will be equal to 0.1 meter. So what is the additive constant, sir? Focal length plus D. This will be equal to how much, students? This will be equal to 0.3 meter if I am not wrong. Now what they are giving, the space between the upper and lower hairs is 4 mm. Sorry, the space between the upper, see, the space between the upper and the lower line of the diaphragm is how much, sir? It is 4 mm. With the line of collimation is at where, sir? With the line of collimation perfectly at 1 meter top, 2 meter at the center and 3 meter. So here what should be the staff intercept, sir? Staff, I told you multiplying constant is equal to what, amma? F upon I, focal length upon I. What is focal length? Here they have given 200 mm. And here see, students, stadia intercept is given as 4. So K is equal to 200 by 4, it is 40. Now see students, staff intercept is bottom minus top. So staff intercept will be equal to 3 minus 1. That is equal to how much students? That is equal to 2 meter. Agree students? So here the line of sight is horizontal. So the distance D is given by the formula Ks plus C. So here what is the staff multiplying constant? We have 450 and the staff intercept is 2 meter plus additive constant is 50. So you will get the answer as 100.3 meter. So you will get the answer how much students? You will get the answer as 100.3. So the option here is option A is correct. So I hope you have understand this solution clearly. Now see students, as I told you in the conceptual series and in the gate score booster, the students who are well practicing and they are going to prepare good for the gate exam and they are very much keenly interested to solve all the problems which are most conceptual, then we are providing all the classroom notes in the Telegram group. In addition to that, we are daily posting the quizzes and whatever happens in the YouTube updates, everything will be posted in the Telegram group. So sincere students who want to get the access to the classroom notes and who want to get in updates from the YouTube when the sessions are going to be held, and apart from that, if you want to have the daily quizzes, then definitely this Telegram group will help you to test yourself. In addition to these students, let me tell you what we at IMS Gate Academy offers. I am proudly saying that we at IMS Gate Academy offers offline gate coaching at Vijayawada, Ben Circle and in Bangalore, Jayanagar. We are offering 800 plus hours of live coaching and as well as offline gate coaching. Here when we talk about the gate coaching, testing yourself is the important parameter. So we offer you 130 plus tests which can be a chapter test, subject test, multiple subject test, advanced level test. And we have the most beautiful test series, that is the All India mock test series. It will be same as the gate environment, how they will conduct for 3 hours. With the same environment, we will be providing you 12 tests. In addition to this, my dear students, we have for every subject, subject-wise material and also exercise book, where in exercise book it contains level 1, level 2, level 3 questions. Apart from this, if you want to solve all the previous 30-year questions with the key pointers and with the video solutions, we are offering the previous 30 years questions with the video solutions and also with the key pointers. This type of material will help you to go through a proper understanding of each and every subject and test yourself. So these are all the IMS features. But remember, my dear students, the key success for IMS Gate Academy is the My Plan session 1-to-1. Here where the student is having any weakness, that weakness can be converted into strength by individual discussion with the individual mentor in his particular stream or particular subject. Apart from this, we are also offering the doubt solving portal student, where if you post the doubt in the doubt solving portal, that doubt will be answered within 24 hours of time. So this is all about the IMS features, students. I hope you have enjoyed this, students. If you really like this, student, we at IMS Gate Academy YouTube channel, we are going to get more and more videos on the Gate Score Booster, which covers all the conceptual problems. And in addition to this, we are giving all the concept problems according to the subject weightage. I hope I'll see you in the next session. Thank you.